but now they'll be able to hear me, but I hope I don't get any echo. So if anybody hears on Zoom, make sure to mute your speakers. Otherwise, we'll get this really fun echo that happens from time to time. And hopefully my mic is okay on my laptop that's picking up for folks on the Zoom. So I'm the Chief Technology Officer at an organization called Paradigm. And we'll talk about what our company does a little later in the presentation, so I won't bore you with that. If you're interested from an academic pedigree perspective, I have 2 graduate degrees, one in computer science and the other in biomedical engineering. Started my career actually in space software, so think International Space Station, Space Shuttle, autonomous spacecraft, and transitioned to healthcare a little later in my career. So I've been in healthcare for over 20 years. So I know if you do the math, it might add up to something that looks older than I am, but trust me, I'm way older than I look. And we won't go there. You can ask me over drinks how old I am if you want, if you're interested. So real quickly, I'm going to just touch on some things about AI. Why I think that's important is, in my opinion, you can ask 5 computer scientists what artificial intelligence is, and you'll probably get 15 different definitions, right? So we should at least talk about like framework of how I think about it, and my historical role in artificial intelligence, because I've been doing AI for over 30 years, actually. How we use it at our company, and then we'll get into a Q&A session. And I will do my best to get us back on time, by the way. And I think I can actually accomplish that. So artificial intelligence, what are we talking about? This is a build slide. I'm not a real fan of them, but that's what our marketing department did. But Merriam-Webster defines it as capability of a machine basically to imitate a human, right? Then you ask ChatGPT, which I did, right? Got to use your OpenAI tools. It's kind of fun to ask AI to define itself. But basically it says the same thing, right? Artificial intelligence refers to development of computer systems to perform tasks that require human intelligence, right? So from branching logic to all these other things. So AI is a part of a broad piece of at least industry, what I would call analytics. So I lead at Paradigm, our technology, data, and analytics group. So what that means is CIO and CISO are part of my organization, the heads of all of our analytics for different product and business lines are part of my organization, and the data science team is part of the organization, right? Artificial intelligence can be done in a lot of different places, for automation tasks in IT, to clinical tasks and clinical operations in the business, to, data science research, if you will, even though in healthcare, we rarely use the R word, because then that immediately, gets you into issues with HIPAA and IRBs and things of that nature. So we talk more on the quality improvement side of things. And you can ask me about why we use that term and what HIPAA means for that. Quick history of AI, right? Because a lot of buzzwords right now, from the years of big data to data science, and now it's all artificial intelligence and conversational and generational AI. And I know we have some sessions on some generative AI and things. But actually, term was born in 1956 at the Dartmouth conference. So AI has been around for quite some time. It started at General Motors, and then moved, not surprisingly, into Carnegie Mellon and DEC, and then into IBM, right, with Deep Blue. That was one of the first systems to sort of beat a human at their own game, right? It beat Garry Kasparov, the best chess player in the world at the time. And you'll notice that in the 50s to the early 70s was kind of this first burst of real R&D around AI, even though some of us might laugh at like perceptrons and other things that were around then. Then it went kind of cold for a little bit, came back and had a big knowledge period where now we were talking about multiple perceptrons and backpropagation neural networks and things of that nature. And then, of course, BPNs and ANNs led into things like support vector machines and things that you probably are still used to using. It got quiet again, and I started getting involved in AI. Sorry for those that can't see me, but this second winter period is where I was doing my master's research, and also where I was in my undergraduate program doing some research in healthcare. And I'll share some of those examples, right? But we got into adaptive learning now. And so now we're starting to talk about the earliest phases of machine learning, where we're now letting, we're not dictating for machines the knobs and dials. We're asking them, you figure out the knobs and dials to optimize error space, right? Or optimize whatever we're trying to predict and things of that nature. So we had a big third burst. This continuation of the line is my prediction, just like Professor De Silva had her predictions. I think this fourth burst is we're at a place where we're reaching the physical limitations of electronic devices, right? We can only make things so small before heat and cooling and a bunch of other things become real problems. So quantum computing starting to get a lot hotter, right? So, and you can do a lot more math with a DNA strand than you can with a 1 and 0 based system, right? It's also a lot smaller too. Ones and zeros and bits actually take more space than genes. So I think quantum computing is going to really do some cool intersectional stuff with conversational generative AI and ... whatever AI we've got coming. So if you think about that technological evolution with what we're doing computationally and from a software side, it's going to be a real interesting place where hardware and software come together. So where did I first get involved in artificial intelligence? So back in 1992, I was doing an undergrad internship at the National Institute of Occupational Safety and Health. And this was in West Virginia at the time. West Virginia, one of their primary industries was coal mining. And so what we were interested in doing is, can I predict when a miner is going to be on the cusp of getting what's called black lung disease, right? And basically, could you use this as a clinical decision support system to say, hey, it's time to get you out of the mine and get you a desk job or find you, retrain you and give you a different mode of employment, right? And so what you're looking at is an inhalation and exhalation curve, and the model's trying to model the exhalation curve. And if you're wondering how we did this, whether it was necessarily the safest thing at the time, time will tell, right? This is 92, but we were aerosolizing corn oil, right? So making it super, super tiny, measuring what went in and what came out of the lungs. And the more that came out of the lungs, the less effective your lungs were, right? And so the flatter this curve would start to get, the more your lungs were being affected, right? And inability to actually, use the oxygen and other things that it was given. So this is a really early example. Keep in mind that artificial intelligence, when it started in the 50s through the early 80s, and no being pejorative to AI, but it's fancy math, right? And to some degree, a lot of it is still really fancy math, stats and calculus and Fourier transforms and Laplace and things of that nature. So fast forward to my master's degree. Artificial neural network is a predictor of adult cholesterol management. Again, a clinical decision support system before that term even existed. We didn't talk about clinical decision support then, but basically had a bunch of biometric parameters, and it was trying to predict your overall change in cholesterol. And the difference in the input, if you notice one of these inputs says center, it was, where was this person? This was from an NIH data set. Where was this person being cared for? Were they being cared for by a physician, which AKA in 99% of the cases meant you were going to be prescribed a medication to control your cholesterol, or were they being seen at a nutrition center by a nutritionist? Therefore, they would be doing diet modification. So given these parameters, we were trying to guess, would you lose more total cholesterol by going and getting prescribed a drug or going and doing diet modification? So in case you're wondering, because you see August of 97, why I didn't jump into healthcare right out of this and instead jumped into space. Well, both physicians and hospitals and other organizations weren't really interested in the late 90s about machines helping them make smarter decisions. It's just a reality, right? And so there was a NASA facility close by and decided to throw my hat in the ring with all the aerospace and electrical engineers, and lo and behold, got a software oriented position. But after about 10 years working with NASA as a subcontractor, by the way, I kind of glass ceilinged and decided to get back into healthcare. I learned healthcare through osmosis. My mom was a nurse for 30 years. So I just, I've always believed in helping people lead healthier lives through computational capabilities, right? I knew I wasn't going to put my hands on patients. Ones and zeros always made a lot more sense to me. But the way I like to tell people is that silly vignette is I just went from keeping a handful of very privileged men and women alive in a nasty environment called space to using the same technological and computational capabilities to keep people alive on Earth. And by the way, we've got a lot more problems down here than we do in space. Space is a really nasty environment, by the way, don't get me wrong, and we can talk about that. But we have a ton of issues on Earth, from our diets to our exercise regimens to, new diseases. And, we could talk about COVID and all of those kind of things. It's interesting, right? Here's just another, there's a lighter side to computer science, right? We don't have to be all propeller heads, so you can actually laugh at yourself a little bit. Here's a website called wombo.art, if you've ever heard of it. It's really cool. You give it a prompt, it uses artificial intelligence to create an image. And they're all very unique and kind of cool. Now you wonder about art students cheating, right? Using this kind of thing. But this is what the title of my master's degree looks like in art, right? And so this is artificial neural network to predict adult cholesterol management. And the thing that I find really fascinating is, okay, it kind of resembles a neural net. And I see some arteries and veins, but down here, which is really cool, it's got a heart. So it picked up the heart from cholesterol management, right? And cardiovascular disease certainly is a big deal in adult cholesterol management. So just another idea. There was a recent article in Fortune magazine. This comes from a Yale Chief Executive Institute presentation, but I thought this was interesting because, there's conceptual elements of artificial intelligence. There's a lot of enthusiasm. Yeah, I just want to, ride the wave and be on the, cutting, bleeding edge. There's folks that have high orders of pragmatism. And then there's those that are like, the end is nigh, right? The AI is going to end the world, right? And you think back to the Matthew Broderick, right? Right. Do you want to play a game? And not so much, maybe with AI. But there's 5 types, if you will, of expert views as it relates to artificial intelligence. I would like to consider myself, as I hope many of us in the room would, to be in that middle part of this Venn diagram, curiously creative, meaning I think it's important to understand all the conceptual components of AI, be really enthusiastic about it, be pragmatic, whether you're doing research or in my field, applying it to business capabilities and leading healthier lives for people, and also thinking about caution. And one of the places I think most about caution isn't the end is nigh, but I think about it in be really pragmatic and cautious about underlying biases that are being instituted based on what you're doing, right? So let's take ChatGPT as an example, right? I had it define itself earlier, or at least what artificial intelligence was. ChatGPT, if you ask it about bias, it will admit that there are 2 fundamental biases that exist in OpenAI and large language models, right? LLMs. One, it's biased by the data it's trained on. Not surprisingly, right? But if you just think about, I'm not going to get political, please don't ask me political questions, but if we thought about it being just trained on Republican data sets, then its answers would probably align to Republican viewpoints. Same thing with Democratic or moderate or conservative. So you have to really pay attention. And why in healthcare this is important is because if we train data sets on those that are most often seen in the hospital or whatnot, we're likely missing underrepresented and underserved parts of the population that don't seek care as often because they don't have the means, or they don't have transportation, or they don't have insurance or something like that. There's always this, underlying bias based on the training data set that you have to be aware of. Number 2, ChatGPT and a lot of artificial intelligence is curated by humans. Well, we as humans walk around with our own set of personal biases. And based on the curation of, let's do like image detection as an example. Yes, that's a dog, but when a dog wears a Hawaiian shirt, that's not a dog, right? Well, I made that decision as a human, and believe it or not, there are tons of humans, especially overseas right now, that are tagging images and other things so that we can do image detection like that. But the human is making that decision on what is and is not that image. There is another insertion of bias. So I always think about those 2 things when I think about that caution part of this Venn diagram, for me, at least. This is a good joke, right? Which I just loved. I had to get it, right? Hey, ChatGPT, finish this building. Okay, that's funny right now, but I bet if I'm presenting this in 20 to 30 years, that's not so funny anymore. And the reason is that we're currently doing 3D cement printing on 3D printers. So we can print foundations of buildings and walls with 3D printers. Once 3D printing gets smart enough to understand how to insert environmental stuff like AC duct work and electrical components and other things, You'll see more machines building buildings, because guess what? Machines might get hurt, but then I don't have a workers' compensation claim, and machines might get hurt, but then I don't get sued for liability, right? And so this is really funny and clever, and I actually love it. This leads to another part of AI and all these things, which folks are on that, you know, the end is nigh, is that AI is going to take my job, right? And what I would say is, no, it's not. However, someone that understands AI and how to use it might take your job. So understand your role in whatever industry you're in, understand how you might apply AI, and don't be afraid of it, right? Leverage it as another tool in your tool belt. That's the other thing where I work that we really focus on is, we're not doing AI or data science just to do AI or data science. If simple statistical linear regression or binomial distributions or whatever will suffice and be very accurate enough, why go complex? But there are some problems that really, really require artificial intelligence and advanced data science. So a little bit more about my company, not meant to be an ad at all. But we're primarily a workers' compensation company. We've been around for 30 years. In healthcare, you've probably heard of something called value-based care. Value-based care means that you not only take clinical, but you also take financial risk. And that's what we do. But we do it for people that have been very catastrophically injured on the job. And what do I mean by that? Things like brain trauma, spinal trauma, dismemberments and amputations, burns over 50% of the total body surface area. Or we have this category, unfortunately, called multiple trauma, which is you've experienced 2 or more of those simultaneously. These cases typically are, on average, $2 to $3 million to resolve, and they usually take 22 to 26 months to sort of clear up. So we have nurses in all 50 states. We deploy people to the home or the hospital of the injured worker. We don't just work with the injured worker, we work with their caregiving network, be it their spouse or their children or their parents or whatever the case may be. But the cool thing is we guarantee both financial outcomes. So we'll take the risk of the finances away from our client, but we also guarantee what's called maximum medical improvement, meaning the best health you can attain given the injuries that you sustained in your on the workplace injury. And we also can guarantee a release to return to work from your physician, meaning you may be partially disabled, but if you can still do the job that you were doing before your injury, we're going to get you back to doing that again. Because for a lot of people that are injured on the job, right, these are blue collar workers and they're in an Amazon warehouse or they're on an airport somewhere and they got crushed by a vehicle, right, on a runway or something. And they're basically the breadwinners for their families. So getting them back to employability is really important for their overall family unit and family structure. So that's what we do. We have a couple of different solutions. I'm going to just build this real quick, and then I'll talk about them. So we have something called Hero Catastrophic and Hero Severe. That's the catastrophic injuries and a little bit less severe injuries that I was talking about. And we have a bunch of AI and machine learning models that we use to predict complexity, predict and calculate psychosocial factors that are affecting an individual. And we have this case acceptance model, and I'm going to show you an example of that when we get to some use cases. We're also using machine learning in our musculoskeletal program. So musculoskeletal program is like, it can be everything from I tore my rotator cuff and I just need some rehabilitation and, some other things, to I have a complex break of my tibia or fibia, and there's got to be pins and bolts placed, and now I've got rehab. So musculoskeletal can be non-surgical or it can be surgical. And we use artificial intelligence to do some triaging and risk classification in musculoskeletal instances. And I'll share that with you as well. We also have a program called Care at Home. This is post-acute care. So this is like you've been discharged from the hospital and now you're at home, and a nurse or a physical therapist or an occupational therapist is coming to home to help you with rehabilitation. And we have a program that attaches to that and helps that at-home care team. And we use some Bayesian models there. And then, of course, our own data science team uses AI when appropriate, right? I mentioned this, right? Predictive modeling, machine learning, natural language processes. But only when we're tackling new domains, like we're wondering, could we use AI to solve this problem? But again, if that's not the tool we need from our tool belt, we won't necessarily pull it out. The other thing that I really want to highlight here, though, is we also are starting to use LLMs to actually help us get faster at providing our answers to the business. So we might ask a chat GPT or just utilize OpenAI itself to say, I have this business problem with these types of data. What models would you recommend are best for solving this problem, right? Because not everyone knows every problem. Back to why, by the way, machines now are accepted a lot more in healthcare. And I'm going to forget where this comes from, but I could find it for you if you're really interested. Someone published an article months ago that basically said, every day in healthcare, we produce so much new knowledge that if a physician wanted to practice at the top of their license every day, they'd have to read for 16 hours a day. Okay, where are they sleeping? Where are they actually seeing their patients, right? Like, you can't possibly learn all of the knowledge that's being produced globally in healthcare now. You have to have machines help you with this. And we're using machines to help us basically say, there's new models developed every day. Help us decide what's best for our business problems. But when you do that, you better have really good data scientists at your employ and by your side to guide and override. Back to the whole data is biased, people are biased, so are large language models. You have to have someone that, pardon my French, can call BS on the answer that it gives, right? Because some really good data scientists are going to go, yeah, I know it said a support vector machine, but that's not going to work here. A random forest is going to work a lot better. Just throwing out examples. I'm not going to get into this, and hopefully they'll make the slides available. I know Marinka said that the presentation was being recorded, so you can go back. But just, what is machine learning? It's a lot of math and statistics, but keep in mind, in artificial intelligence, there are two big domains: supervised learning and unsupervised learning, right? And ML is a lot of unsupervised learning, right? Supervised learning is like the old school backprop neural networks, and support vector machines have a lot of knobs and dials that humans have to pay attention to and tweak, and let me adjust my alpha and my beta and my training set versus my testing data set. Oh, there's so much fun with all that stuff. Or you do unsupervised, which I'm a big fan of. It says, just let the machine loose and let's see who wins in the error and predictability and accuracy. So a couple of examples, and hopefully you can see this. It's a bit of an eye chart, but this is the musculoskeletal risk assessment. I've hidden the actual factors over there because my organization asked me to. It's intellectual property, and even though we've been around for 30 years, we have some competitors, but I did bring a cheat sheet that I can at least tell you what are these things. By the way, you're looking at something called, and the other one will be so as well. This is almost like a Shapley distribution curve, right? That says how much things do or do not either produce an effect for acceptance or rejection, basically. So what are the clinical measures that we're talking about over here? Just to give you some examples: pre-existing conditions, in other words, comorbidities. So you broke your leg, but it's really important for me to understand that you have diabetes and cardiovascular disease, right? Because that's going to factor into the overall care plan. Body mass index. Have you screened positive for depression, right? Are there other socio-behavioral things going on? Demographic factors are, of course, age. That's a little depressing, by the way, but does anyone ever thought of this? I'll give you the depressing healthcare vignette of the day. We're all born with a comorbidity. It's called age, right? No one's getting out alive. Every day that goes by. Language literacy is actually a really important factor that we've found. And does your care team speak your native language, right? Some self-reported measures. Is there a lawyer involved in workers' compensation? There's oftentimes attorneys involved in these types of things, and that actually makes a difference. And we also use things like substance abuse, tobacco use. And one of the more interesting things from a self-reported perspective is something that we call injustice experience, meaning, do you feel like you're experiencing injustice in the healthcare system? Are you being treated unfairly, whether it's due to ethnicity or race, or you don't speak the native language, right? Like, let's say that you got hurt overseas and you're a native English speaker or whatnot. You might feel like the healthcare system's not treating you fairly. Well, what we've actually found is if you feel like you're experiencing injustice in the healthcare system, your care will take longer. Your rehabilitation time is longer. So we factor those things in, right? But anyway, we come up with this risk assessment, and then to our care team, not just our business people and, you know, a bunch of us nerds that love data, but we provide this to our clinical teams, and we go, okay, low psychosocial risk, low functional status risk. Functional status means, are you able to ambulate and walk around? Are you able to communicate with me? Things of that nature. But high risk due to pharmaceuticals. Might be on opioids as an example. You're in a lot of pain, right? You might have had some musculoskeletal thing, but there's evidence of potential abuse, or you have the right factors that lead to potential abuse. Let's watch the pain medication regimen here. Medical surgical history, meaning this person's had prior surgeries. So that plays a role. And in social determinants of health, you probably have heard of SDOH, or social determinants of health, but social determinants of health are things like, do you have transportation? Do you have someone at home with you? Do you have a support system, right? Et cetera, et cetera. But overall, you can see that even though there's some red things, this is green. We want to manage this person, by the way, because there's some really complex stuff going on. But overall, we think that this is going to be a relatively low risk case to manage if we take those things into account appropriately. So this is a musculoskeletal example. This is the catastrophic stuff I was talking about. So these are really nasty injuries where basically not only does the individual experience the worst day of their life, but their family members around them do too. It's often the case that people that have these catastrophic injuries experience much what we would call PTSD, right? Post-traumatic stress syndrome, or their caregiver does. Not surprisingly, because of these really nasty injuries, sometimes they're either in a coma themselves or they're in a drug-induced coma because of shock and a whole bunch of other things that we need to stabilize them. So who's experiencing the trauma from that? Well, not them necessarily. Physically, of course they are, but their family members are, right? Their wife or their husband or their significant other or somebody else, right? A child perhaps is having to care for their dad that this happened to. So you have to think about not only the person that's in the hospital, potentially in a coma, but how am I going to care for best their child? And how am I going to consider that as part of my overall care plan? So this is a Shapley contribution graph. I had already talked about that. Just to give you some other examples of things that we use here, clinical measures are very similar. Pre-existing conditions, your body mass index, depression, anxiety, those kinds of things. Demographic factors, age, of course, but also language literacy is really important here too. Not can I just speak to the injured worker, but can I interface with their family and caregivers, right? Self-reported measures, these are interesting. I didn't flip the page, by the way. Demographic factors, age at time of injury. And one of the things that we found that's interesting and important is residence type. Are you in a home? Are you in a mobile home? Are you in an apartment? Are you in a complex? Are you in a retirement community? That type of residence is really important because it affects the ability for you to have transportation and rehabilitation and a bunch of other stuff. Clinical measures, the injury complexity, right? Brain trauma and spinal trauma are really complex in and of themselves, but there are multiple layers of complexity. Where was your spinal issue? Like if you fractured your spine, is it high up on the cervix or is it much further down? That actually determines likelihood of being paraplegic or quadriplegic and a whole host of other things, including future back surgeries, as an example. You know, one of the interesting things about healthcare is once you have a back surgery, you're probably going to have another back surgery. It's just like a dot, unfortunately. We also look at the target outcome level. Like what outcome level do we think that you can attain? And that's an important indicator of risk. Value-based contract. Remember, I mentioned that we're a value-based company, so we take on both financial and clinical risk. And so we have a bunch of value-based factors here. Is there an attorney involved? Because that affects things. Known versus unknown costs. For a lot of these things, we know, oh, if you have this type of burn, we know you're going to have these 7 things done in the hospital or in rehabilitation. But there's a whole bunch of unknown stuff as well. And so we include what we know versus what we don't know, actually. And we look at days on hold. And what days on hold means is how many days have you been in the hospital unable to communicate with us? Because that ability to communicate with the injured person actually affects the outcome and the risk of this overall thing. But what this would say, if you look at the very top, is that we're predicting, yes, we would reject this because there's contraindications. And there's only certain things down here that are saying that we should accept this case. So what we would do actually in this case is we would say this isn't enough to have a catastrophic care team, but we would assign a lower severity care team, right? So this injury wasn't so catastrophic that it needs all of that big, bulky wrapper and really healthy, robust care team. It needs something a little lighter, right? Like case management or just at-home care or at-home rehabilitation or things of that nature. So, hey, I got us back on time. But any questions, either my musings on artificial intelligence itself or how we use AI at Paradigm? Yes, please. And I'll try and also look at the chat window if anyone's out there and would like to ask a question on the chat as well.
Yeah, it was a great presentation. You just mentioned a few things like, do you have support system, transportation system, or indications of depression and things like that? I guess like the degree of such things might vary, like it can be subjective from person to person, because given two people in the same situation, they might say different reactions to that, whether in terms of all the subjective parameters. So how does your AI models try to model these variations which comes from individuals?
Yeah, so great question, right? Subjectivity versus objectivity. First thing we do is try and use validated instruments to measure those things, right? So for depression, as an example, there's a short screening called a PHQ-2. There's a longer screening called a PHQ-9. So we ask them to answer those things because from a self-reported perspective, those have been validated through clinical trials and other things. So first we try and use validated instruments to capture that self-reported data. That gives us a higher order of confidence, but also it lowers the error bars, if you will, right? So that's one. Back to the subjectivity versus objectivity, therein lies the complexity of self-reported data, I'll just say, right? Because we're all humans. And so the models themselves actually will tease out quite a lot about, we might literally capture or our nurses will capture 20 self-reported measures when they're speaking with the injured worker and their family, but we might find that only 3 are actually relevant, right? And so through actual AI and modeling, we'll toss out and ignore the other 17 things that we captured, right? And only include those. So both those examples that I gave seem like a relatively small data set. Keep in mind, they were run on probably 400 parameters. Those 10 to 12 are those that really matter to the contribution of accuracy. Yeah, it's a very fair question.
Oh. Thank you. This was very interesting. My question is related to when do you think we will hit an inflection point where our decisions are going to be driven more by this than not? What I mean by that is right now, we all in all of our respective industries have best practices that were developed mostly by humans. If we do not follow said best practices and get in trouble, then we might get in trouble, but look at the best practices. Right now, as far as I'm aware, no best practice says do what the AI says. Well, you have such a large data set, I can't know everything. At some point, that might be a best practice. Where do you see that kind of coming? How far away are we from that?
Yeah.
Question I know, but
so I'm gonna repeat the question. I was just asked to do that. So and tell me if I do an okay job of reading this back. But the question was, when do we start to trust the recommendations of AI such that we don't need humans intervening anymore? Just to a lesser or greater extent. And what I would say is back to that whole, is AI going to take my job? I don't think it really ever does. I think it is just orders of how much does it augment what you're already doing. So I'll give an example of another talk that I did where a physician brought up a great point. I don't know if you've seen this, but ChatGPT has done a couple of impressive things, right? ChatGPT has got its medical license in all 50 states. Not hard, it's rote memorization, right? I'm not actually surprised that it could pass a bar exam, if you will. I'm meaning a medical bar exam, if you will. But the more interesting study, and this was a randomized controlled trial. So this is legit, and I can give you the references if you like, and just contact me afterwards. But 8 out of 10 patients find ChatGPT to be more empathetic than their physician. And a physician at this conference took a big beef at that, right? And was like, well, and I said, you've brought up an amazing point, which is right now, our healthcare system is what's called fee for service, meaning physicians are paid more for volume than they are for value, right? And so it's a turnstile. You get 15 minutes. How can you possibly know a person, have read their case beforehand, and be empathetic about everything that's going on, like their dog that just died or their kid just got diagnosed with something new, if you don't have time to spend with them? And so my point was, you have a great point. If we can change the way that our healthcare system works in the United States, you'll have more time with your patients. And oh, by the way, we shouldn't be hospital-based. We should be more primary care. Is anyone old enough to remember when docs made house visits? Right? And they knew you and your family, and they knew everything that was going on, and they could make much more heartfelt decisions to the betterment of your entire family unit, if you will. And sorry, I know I'm rambling, but I'll come back to your question. But the problem is that ChatGPT does better because our physicians don't have enough time with our patients, but ChatGPT has a ton of that knowledge, right? And if ChatGPT can go out and gobble your LinkedIn and your Twitter feed and a whole bunch of other stuff, it can personalize it to you. And that physician didn't have time to go and do all that homework, right? That's a real challenge, right? And that's where machines just start to augment more and more of healthcare. So my answer to you is, I don't think I can put a flag in the timeline of history and go, here's where machines take over. But I think that more and more of our lives become augmented because in certain aspects of industry, like healthcare, we don't have enough time to spend to gather all that information. So let machines do it for you, and then it augments, right? How cool would it be if before a physician saw you, the nurse sicked ChatGPT or some other large language model on all of your information, and they came in and they were like, oh, well, first of all, congratulations on your granddaughter's wedding, and I see that you know, one of your cousins just graduated from Stanford. That's awesome. Oh my gosh, I now have a physical connection. The doc, you know, said there's some cool things that are happening in my life. That would already started out on a better foot, even if he had bad news to give to me. My point is, I think it's all about augmentation. Whether it's glasses you're wearing that, by the way, I know a lot of you probably are aware of this, but both from a augmentation in a factory floor where people are building things like airplanes to the metaverse, right? The reality is more and more of our jobs are going to become augmented by virtual reality and by artificial intelligence. And so I think the cool way to think about it is, let's give that work to the machines, and let's find really more creative ways to use our human minds. Because by the way, humans have created all this stuff that we're talking about. So let's create the next thing and the next cool thing, and let the machines take care of that rote work, right? I mean, how many folks here have a Roomba? I love those little guys, right? Oh, I don't have to sweep the floors quite as often anymore. I still have to mop it, but you know, anyway, that's an example, by the way, of something taking. Oh yeah. Right. Yeah. Dr. De Silva's talking about something that I very much believe in and my son is against, right? So teenager versus dad, is that I'm not a first technology adopter. You know, I wait till V2, V3, and then I'm like, oh, okay. So I usually skip 1 or 2 generations of iPhones and then wait, right? When they took the push button away, I was so bummed. I'm like, wait, what is this swipe up now in your face? And but actually we use it now for multi-factor authentication. My company's passwordless. We don't require people to remember passwords. My laptop is connected to my Bluetooth, and it knows that this phone is my phone and my phone only. And guess what's required to get into my phone? My Face ID. So I get into my phone, it verifies to my laptop, and I log in. I don't remember passwords anymore. That's another example, by the way, of a machine helping me get rid of something. Now I don't have to remember passwords. Just some silly examples, even Roomba, right? But Roomba takes a rote task, and now you get to devote more time with your kid, or go beekeeping, or go jam out, you know, if you're in a band or something. But it allows you to do more either personal or professional exploration. One other question, and I think we're going to almost be at time.
Quick question about the MSK.
Yes.
Assessment sheet. Are you including any monitor or using computer vision to see how the patients are moving within the assessment?
So the question was, are we using any like time and motion studies, basically?
Yes.
Right? Yes, we are. Yeah, there are validated instruments, depending on the body part that we're talking about, legs versus hips versus shoulders, that actually do the range of motion studies. Yes, that's part of the clinical assessment that we do either at the hospital or in their home, and then that gets fed in. Yes, and of course, we actually can watch over time how they progress, and we can start to predict, are they ever going to get full range of motion, or have we plateaued? Right. And so if they've plateaued, and we based on, the 100 of other cases that we've seen like that, know that, it's likely not going to get better. Let's not waste time with more rehabilitation. Better for them, spend time on something else. Better for the healthcare system. It doesn't spend money on that wasted treatment, if you will. Yeah. So for treatment optimization, you bet. Yeah. Yeah. Please.
Hey, Jason, thank you so much for the great talk. Okay, thank you, Jason. Actually, I have probably a comment. I'm being a former IBM, actually, in your history of AI, I would like you to insert one more bullet, right?
Okay.
Around 2011, IBM Watson. And that's really, I would consider it really the beginning of the new upward trend of this AI.
The Jeopardy.
IBM Watson Jeopardy.
Yeah. So I'm going to close the chat window so it's not consuming space. But you would put Watson about after Deep Blue, like here.
Yes, 2011.
Yeah. So like right here, right? Which was kind of at the end of our third burst. Now, interestingly enough, I'll bring in Dr. De Silva's talk into this, since we're talking about Watson Health, right? Supposed to be the panacea for healthcare and predict and do all these things, right? You know where I'm going to go with this, right? It failed in certain instances at the Cleveland Clinic and at Mayo and a few others. Why? Healthcare is really complex, by the way, really, really complex. When you get down to the individual person, their genome, their exosome, and everything else, right? Machines have limitations, and Watson was a fantastic research instrument that made us all smarter on the complexities of healthcare and things of that nature. But at the end of the day, it wasn't making enough money for IBM. And so IBM is spinning Watson off. They're actually selling it. And so that's interesting, right? That this awesome research tool didn't show the business value that an organization that at the end of the day is publicly traded and therefore watches earnings per share very closely, didn't see the ROI. And so now they're deciding to spin it off. Like Watson's going to become its own company, or it will get acquired by somebody else. And the only reason I mention that isn't boo Watson. No, Watson was really cool and did amazing things. My point is, you kind of have to be aware, whether you're in research, in academia, or in industry, there's a confluence between all the cool stuff you can do and the business value that's derived from it. And if you don't find that sweet spot of awesome innovation and also driving business value, it's probably going to get waved goodbye to at some point. And it may not be tomorrow, it may be in a decade, but there's always a short, a mid, and a long term, to Dr. De Silva's point, as it relates to innovation and confluence with business outcomes. Yeah, there's a great point though, and I'm glad you made it, because it added a nice end to this conversation. Okay, well, thank you so much. I really appreciate it, everybody. Yeah, thank you.